In this video, we will apply the concepts of AP and the concepts of GP to solve real-life application problems. Now, talking about problem solving, many students face difficulties in this type of questions, and you can really improve on your problem solving strategies and heuristics by taking care of a few factors. Now, according to Charles and Lester, there are three factors that influence your ability to solve the problems, mainly experience factors, which includes factors such as your content knowledge, which you can accumulate by studying hard, the familiarity with solution strategies, familiarity with problem context and content. Now, this can be improved with practicing and exposing yourself to more questions. Your problem solving ability also depends very much on your affective factors. Now, such as your interest, your motivation, your pressure, which means, like, for example, for some students, they can't solve problems in the exams because they can't manage the reaction to pressure and anxiety. The tolerance for ambiguity, for example, certain questions may not be so well defined, so how are we comfortable with that? Your perseverance and so on. Of course, if you are a very persevering person, you believe that you can solve it and you keep trying, now of course eventually you will be able to solve a problem. These are areas where the students can help themselves with a lot of self-encouragement, and you must want to win, and you have to use a lot of positive self-talk. When you believe in yourself, you will have a higher chance of being able to solve the problem. Of course, you always doubt yourself, you don't think you can solve it, you will never be able to do well in this kind of problem. Finally, the last factor that will affect your ability to solve problems will be your cognitive factors, such as your ability to read the question well, your spatial ability, analytical ability, logical ability, computational skills, and your memory and so on. Again, we firmly believe that these skills, reading ability and so on and so forth, can be improved by practicing more problems with your friends, and when you discuss with them, you will think much better. So I hope when you encounter problems in solving complicated application questions, you don't give up but believe in managing and improving yourself. Now, in problem solving, a very useful model is George Polya's 4 phases in the process of problem solving. Step 1 is understanding the problem. The questions that you should be asking yourself is, what am I given? What do I need to solve? And what you can do is, now look for information given, read carefully, visualize the information, organize the information. Probably you can make a table, start writing some numbers down, and try to connect information together. Step 1 was understanding the problem. Step 2, we need to devise and make a plan. In general, step 3 will be on carrying out the plan, and step 4, you look back at the completed solution and you check whether your solution is reasonable. Now, what do we mean by devising or make a plan? After we have understood the problem, we will probably need to ask ourselves, what formulae or theorem can be helpful in this question? Have I solved similar problems before? If you have solved a similar problem before, you may want to try the similar strategy. Can you break the big problem into smaller problems to solve? If you can't solve the whole problem, can you solve part of it? Have you used all the given data in the question? Now, when you're trying to devise a plan, you can think of the following strategies, which all of you would have been exposed to in secondary and primary school. Skills such as making a representation, draw a diagram, make a systematic list, use equations, of course, make a calculated guess and check, look for a pattern, making supposition, right? Go through the process, act it out, work backwards, before and after comparison, change the problem. Now, I'd like to highlight a few of them that are more applicable or most common in A-levels, such as drawing a diagram in vectors, in the topic of vectors, maybe making a systematic list when we are solving P and C questions, permutation and combination questions, using equations. Sure, in A-levels, in every topic we need to use equations. Look for a pattern. That is very important, especially in this topic of APGP. Well, work backwards when we need to prove problems. When we are trying to prove a statement, change the problem. Change the problem, probably restate the problem. And this type of question that I'm highlighting is in the next topic, sequences. When we need to prove the n+1 term being bigger than the nth term over here, what we can do is we can rephrase it. We make the right hand side 0 and we prove the second inequality instead. So we can finally try to simplify the problem and solve part of the problem, as I've mentioned before. Sometimes when we do all this, like solving part of the problem, restating the problem, the strategy to solve the problem becomes clearer, and from there we slowly will be able to solve the big problem. So in the process of making a plan, we can consider this. Step 3, carry out the plan. Now when we are carrying out the plan, we got to be very careful in using our mathematical knowledge, skills, logical thinking. We need to exercise what we call control skills. Mainly, we need to be taking note of our own thinking, noting down, being careful in making decisions on what to do. For example, shall we factorize here or shall we expand here? So we need to build our control skills, and control skills can be built up through practice. So after we have solved a question, we want to look at the completed solution, and we need to do some checking. We want to ask whether our finance is a reasonable one. Are our steps clear, logical, and error-proof check-through? Well, probably you want to check the answer with a calculator or substitute back to see whether the answer is reasonable. Can we obtain the same answer via another approach? Or can I use the method for some other problem? We'll try to check and extend our solution. Now, when we do these 4 steps of understanding the problem, devising the plan, carrying out the plan, and looking back at the completed solution, please note that these steps are not always linear. Now, what do we mean? Let's say we thought we have understood the problem and we devise a plan to carry out, to solve the problem. Well, carrying out the plan, we may note that the strategy may not be appropriate, or there may be certain parts that or certain conditions that we might have missed out, and we will always go back to re-understand the problem, and we'll go back to reinterpret the problem, or maybe we want to check whether we have missed out any information again. So from there we can see that we can always go back to previous steps and re-attempt the problem a couple of times before we can arrive at a good solution. This is quite normal when it comes to problem solving. So please do not be discouraged when you get stuck right from the very first attempt. Okay, now we shall demonstrate here how we can apply Polya's model to solve example 60 in your lecture notes. Now, First step, what do? We want to understand the problem. We'll apply the Polya's 4-step model to solve part 1 and 2 here. First, let's try to understand the problem. A bank has an account for investors, so interest is added to the account at the end of each year at a fixed rate of 5%. We know 5% means 0.05 when it's converted to decimal. At the beginning of that year, a man and a woman both invest money. Now, part A. The man decides to invest X dollar at the beginning of 1 year, and then a further X dollar at the beginning of the second each subsequent year. That means at the beginning of each year, he'll just keep putting X dollar in. He also decides that he will not withdraw any money out. That means we don't subtract anything from whatever figure we get. Alright, now part 1 wants us to work out how much will there be in the account at the end of 1 year, including the interest. Part 2 needs us to show that at the end of n years, where the interest for that last year has been added, he will have a total of this in his account. So how are we going to solve this 16a part 1 and 2 first? Okay, let's take a look. Now, first let's try to understand the problem. When we try to understand problem, probably we want to take note of our affective domain first. What do I feel about the problem? That's the first question I probably ask myself. Well, to me, the problem looks complicated. I need to read every word very carefully, and I highlight keywords, and I probably need to write down some numbers before I feel that I have a clear understanding. It looks rather challenging, and I may need a few attempts before I can solve it, but I believe I can solve, even if more than one attempt may be needed. And when I believe I can solve, and I'll keep trying, when I reread and reread and reread, I'll be able to pick out information and see from alternative angles. Alright, now after that,